Hello and welcome. In this video we will learn about Newton's second law and complete calculations between force, mass and acceleration. So sit back, relax and enjoy this lesson on Newton's second law.
Newton's second law states that the acceleration of an object is directly proportional to the resultant force applied and inversely proportional to the mass of the object.
Newton's second law. The acceleration of an object is directly proportional to the resultant on the object and inversely proportional to the mass of the object. What this means is, if the force is increased, so does the acceleration. So the bigger the force, the bigger the acceleration. Alternatively, if you increase the mass, the acceleration of the object will decrease. So a bigger mass is going to make the acceleration smaller. Terminal velocity is when air resistance equals in magnitude to the weight of the falling object, or buoyancy equals to the downward force. Acceleration at terminal velocity is 0. In the first part of the image, you'll find that the weight is larger than the drag force. In the second bit, the weight is still slightly larger than the drag force. Eventually, the drag force and the weight are equal. The acceleration at terminal velocity is now 0. In Newton's second law, we can see that as the force increases, the acceleration increases. So looking at this graph, we call it a directly proportional relationship. When one increases, the other increases. When you look at the equation, force is equal to mass times acceleration. More force equals more acceleration. However, if you increase the mass, your acceleration will decrease. This is an inversely proportional relationship. To try calculation, we could say, calculate the resultant force on a sprint of mass 80 kilograms which accelerates at 8 meters per second squared. Use the equation force is equal to mass times acceleration to give you 80 kilograms times 8 meters per second squared, which is equal to 640 newtons. Here's an example for you to try. Calculate the acceleration of a car with the mass of 800 kilograms acted on by the resultant force of 3,200 newtons. Pause the video and give it a try. You could use the equation acceleration is equal to force divided by mass. That's 3,200 newtons divided by 800 kilograms. Your answer is going to be 4 meters per second squared. A further example, or an exam type question, could be the following. A roller coaster car stops above a vertical drop. Suddenly it falls under gravity. The drop is 60 meters high, and at the bottom of the drop the car travels at 125 kilometers per hour. The acceleration experienced by the people on the car is 10 meters per second. The mass of the car and its passengers is 1,210 kilograms. Calculate the force exerted on the car and its passengers. Show your working.